Alright guys, welcome to 2.5 video literal equations and formulas. After this lesson I will be able to rewrite and use literal equations and formulas. Here we go. You're ordering pizzas and sandwiches. You have a budget of $80. How many sandwiches can you buy if you buy 4 pizzas? What about if you buy 5 pizzas? And explain. Okay? So pretty basic here. So $10 for the number of pizzas. So however many pizzas multiplied by 10 plus $5 times the number of sandwiches gives me a total of $80. And they're saying, okay, well if you buy 4 pizzas, how many sandwiches can you buy? So I'm just going to simplify my little equation up here. So if P is the number of pizzas and S is the number of sandwiches, my equation would become 10P plus 5S equals 80. Hopefully that makes sense to you. 10 times the number of pizzas plus 5 times the number of sandwiches is $80. Now they're telling me how many pizzas I want. So in the first part they're saying if you want to buy 4 pizzas, so I'll just make P equal to 4 and I'll plug it in. And if I simplify this, I'd get 40 plus 5S equals 80. Subtract your 40 from both sides to get the S all by itself. 5S is 40, divide by the 5, and S is 8. So I can buy 8 sandwiches. Second part of the question asks me, okay, what about 5 pizzas? So I'll just make P5 in my equation. Just make P5. And what I have here is 10 times 5 plus 5S equals 80. So 50 plus 5S equals 80. Subtract the 50. 5S makes 30. Divide by the 5. And S is 6. Okay, so it's pretty simple as long as you can establish some sort of equation and they're giving you a value for one of the letters, just plug it in and simplify it. In this lesson, you will learn to solve problems using equations in more than one variable. So notice in this equation there was P's and S's, so there's 2 variables. A literal equation is an equation that involves 2 or more variables. All right? When you work with literal equations, you can use the same method of simplifying equations that you learned previously to isolate the particular variable. All right, here we go. Let's take a look. Equation 10x plus 5y equals 80, where x is the number of pizzas and y is the number of sandwiches, models the problem that we just looked at. All I did is I changed the p's to x's and the s's to y's. So what they're asking me to do is solve the equation for y. So that means get the y all by itself. So isolate the y. So if you take a look at that equation, the 10x is on the same side as the 5y. So I have to get rid of this 10x. So in order to move a 10x, I would subtract 10x from both sides. Now you have to be careful because you can't subtract 80 minus 10x. They're not like terms. Okay, so I wouldn't get 70x or something like that. The right side will just be 80 minus 10x. Or you could write negative 10x plus 80. Okay, so when you take it over here, make sure you do not stack it underneath or you might be tempted to actually subtract those numbers. But you can't do that because they're not like terms. So I usually just throw it over here to the side. All right, now I got 5y equals 80 minus 10x, but I have to solve for 1y. So in order to get that 5 off of there, all I'm going to do is divide by 5. If I divide by 5 on the left, I have to do it to the right. And there's more than one piece on the right, so I have to make sure to divide all of those pieces on the right by that 5. 80 divided by 5 is 16. Negative 10 divided by 5 is negative 2. So since it's negative 10x divided by 5, it would be negative 2x. So I get y equals 16 minus 2x. Another answer would be y equals negative 2x plus 16. Either order would be fine. Okay, so it's really the same operations you've been doing for the last couple sections. Add or subtract to move the things, and then divide. Just remember when you divide, you got to divide all the pieces. So that's what this section is all about. How many sandwiches can you buy if you buy 3 pizzas? Well, now that we have that equation there, y equals 16 minus 2x, it's actually pretty simple to plug it in. So if I just take the 3, and I know that x is the number of pizzas, and I plug a 3 in here for x, I would just wind up with y equals 16 minus 6, which is just 10. If I want to know 6 pizzas, well, since x is the number of pizzas, just take it and plug it in, and you get y equals 4. Okay? So you could have used the original equation, or this simplified, for y equals equation is a little easier to use in this kind of situation. Let's take a look at a couple more examples. Solve the equation 4 equals 2m minus 5n for m. So I want to get this m all by itself. So I need to isolate the m, get the m all by itself. So I take my same rules as before. I have to move this negative 5n away from the m's. So in order to get rid of a negative 5m, I would add 5n's to both sides. That would cancel these out over here. When I do it to the left side, just be careful that you don't actually add these numbers together because they are not like terms. So over here on the left, you would just have 5n plus 4 equals 2m. Now I got to get this 2 off of here. So I'm going to divide it by 2. Remember, anytime you divide it by 2, you got to divide all of the pieces in the equation by the 2. So m would equal 5 over 2n plus 2. All right, 5 divided by 2 is literally 5 over 2. If you don't like that and you want a decimal, by all means, make it a decimal. 5 divided by 2 is 2.5. Okay, so 2.5n plus 2 equals m. I was able to isolate the m, get it all by itself. I solved it for m. Okay, and then they're just going to give me some values. So now I have my equation, 2.5n plus 2 equals m, and then they're going to give me some numbers they want me to plug in for n. So I'll plug in negative 2, and then I'll plug in 0, then I'll plug in 2. So that's a pretty simple thing to do. Anywhere you see an n, put a negative 2. Simplify it. That's negative 5 plus 2, which is negative 3. The next part asks me to plug in 0 for n. So start with your original. Take your 0, plug it in, simplify it. Then they ask me to put in 2. So take your 2 for your n, plug it in, simplify it. There it is. Okay? All right, here we go. So now we only have variables. There's not even any numbers to work with. So same operations as before, solve it for x. In other words, get the x all by itself. So if I look here, this one could be a little tricky because I have x's in this piece and x's in this piece. So somehow I got to get those x's out of there. If you think about what this looks like, in reverse, it really looks like this. When you had a distribution problem and you did x times a, you would have gotten ax. And x times b, you would have gotten bx. So another way to write this top piece would be to write it like this, as a reverse of the distribution property. Okay? So that's a tricky little advanced move there. Pull out the x times a is ax, x times b is bx. So I can rewrite this top left part as this. And now what I'm able to do is now I have x times this thing, so I can just divide both sides by that thing to get rid of them off of the x, and I would just wind up with c divided by a minus b. Okay? So don't let the fact that it's just letters and not numbers freak you out. It's really the same things you've been doing with the numbers from the last couple sections. All right, here we go. So solve negative t equals r plus px for x. So I got to get the x all by itself. Notice the x is over here on the right with a p stuck to it. Before I can divide by p, I got to get rid of that r. So to move that r, I would just subtract an r from both sides. When I do it to the left, I got to do it to the right. I can't subtract r and t. Okay, so they're just going to be negative r minus t. They're not like terms. I can't put them together. Now I have a px. Remember, px means p times x. So in order to get rid of the times, I would do a division. Whatever I do on the right, I have to do on the left. So I just have really negative r divided by p and negative t divided by p, which I can just write as a one-piece kind of thing like that. Okay? So negative r minus t, all that divided by p is equal to x. Okay? Last couple slides here. A formula is an equation that states a relationship among quantities. Formulas are special types of literal equations. Some common formulas are below. There they are. Notice that some use the same variables, but the definition of the variables is different. So, for instance, some formulas, like here, the R stands for the rate, but here the R stands for the radius. Okay, that's what that means. And this formula we can find on page 110 of our text, whether we look in the hard copy of the book or online electronic version. Okay, so what do I want us to do with it? The radius of the circle with circumference 64, round to the nearest tenth, and then they tell me to use 3.14 for the pi number. So if I look at my formulas here, I'm looking for the radius of the circle with circumference 64. So I look for my circle formulas. There's one here, and there's one here. And then they want me to deal with circumference. So it looks to me like I'm going to use this formula right here. C equals 2 pi r. Pi is just a number. Okay, and they're telling me what number to use, 3.14. You do have a pi button on your calculator, which you could also use. Okay, so let's plug in what we got. I'm looking for the radius, so that's still going to stay with an r. Circumference is 64, so the c is going to become a 64. The pi is going to become a 3.14, and again, I'm looking for r, so he's going to stay in r. So if I just plug in what I know, 64 was the circumference. 3.14 was the pi number. All right, and if I just simplify this side, 2 times this is 6.28 r. In order to get the r all by itself, I got to divide both sides by that 6.28. So r is about 10.2. So the radius would be about 10.2. So pretty simple. You got a formula, and they're telling you what to plug in and where to plug it in. And that's all you got to do. Here's another one of those. The height of the triangle. Find the height of the triangle that has an area of 24, base and length 8. So look at your formulas, dealing with triangles. All right, there's your triangle formula that deals with area. Okay, so there it is. Area equals 1/2 the base times the height. So they gave me the area was 24, so I'll plug in the 24. They gave me the length was 8, base length 8, so I filled that in. My job is to find the height. By the way, I think on your paper I had a misprint. So make sure it reads, what is the height of a triangle? So when I simplify this over here, well, clean it up before you do anything else. So 1/2 times 8 is just 4. Now I got to get the h all by itself. So divide both sides by 4, and h is just 6. Okay? So pretty straightforward. They gave you a formula, and all you got to do is plug in what you know, find out what you don't know. That's it. I'll see you next time. Peace.